can see F0 equal to what? F0, we can see it is the limitation of Ft. This t tend to 0. Okay? It is to this, equal to this. Now, if this t tend to 0, now we should use this condition. Which is known. Now, it is equal to this, equal to S Fs. This big Fs is the Ft, is the Laplace transform of Ft. Now, this S equal to unity, Then we compute this F0. If F0 is the limitation of Ft, the t tend to 0. Now, this condition is tell us the Laplace transform of Ft is 1 by s plus a. So, it is equal to s by plus 1 by r, 1 by a. This is 10 to empty, empty. Now, what's this result? What is this result? Now, it is, we can say s plus s a. Now, because s is 10 to infinity, so here is infinity. Then s plus a is also infinity.
Yep.
So we can
0.
S plus a minus a, also s plus a equal to 1 plus 1 minus a, and s plus a. This a is a constant number.
Yeah.
A constant number. But this s is 10 to infinity. So this part equal to 0. Yes. So all this equal to 1. So the result is 1. The result is 1. And then this f empty. Now equal to what? Now f empty. This is ft. Now this limitation is t tend to empty. That is ft. This t is tend to empty. Now it is equal to s fs. Now this s tend to 0. Okay. Here also s plus a. You can see here. Now for this fraction, we need not do like this, because this s tend to 0. So this part is 0, and this part is a. So it is equal to 0. No, this is the solution of this the first example. The first one, you can read it for some minutes. tend to 0. And then convert to this s tend to infinity. This is true. Is rotation. Then the variable is t, and this variable is s.
And then this one, how can we get
this s, we should remember this formula. This formula I have write down on the.
This one,
yes.
This one.
Now, any question? Good. If I have many, if you have a question, you can ask me directly. Okay? Now, if you have no question, we can continue the second example of the second example.
No.
Okay.
What's the big one? I don't know. How to get one? Yeah.
Here is A. Now, how to do this one? Because this S is 10 to infinity. We can say P is infinity. Now, this S is 1 to infinity. So, this fraction, we can say, so this part S is infinity. S plus A is 1 to infinity. That the two part is equal, maybe are all infinity. So we should this S plus A and the limitation of S tend to 0 infinity. Yes, and this is infinity. This is also infinity. Yes. Now we should give this. Maybe this power of this is the same. So we shall write as 1 minus A and S plus A. Here is 10 to infinity. This is this equal to this. The two parameters is equal to each other.
What is the minus?
Minus 1, this is a break. This is minus 1, minus. And A is a constant number. And this A is what kind of number? S tend to infinity. So this part, this branch is 10 to 0. We can now this the result. Now I give you some another example. This now this S is turned to infinity. What is the result? We show the first limitation plus 1 and minus and then now equal to limitation 1 by 2 and minus 2 and plus 1. Now S tend to infinity. Now if S tend to infinity, this here, this part is 0, but the result is 1 by 2. The two examples I give you, and can you understand what's the meaning? So first we should to try to deal with this part. Okay.
Suppose if there is 0, how we get? So how to get the result?
How to get the result? Because the limitation of the result S, if S tends to infinity, it is 0. And this S 1 by S s equal to 0 is empty. Let's go. The second example, we shall do it. How to do it? How to do it? The initial condition of it is y0 equal to alpha, and y factorial duration is beta. Now we should solve this differential equation. Slow it. Now we should do it. How to do it? For this equation, we can write this Laplace yt equal to ys. Now this what? Equal to what? Would you like to write down the result? The second duration of yt, the Laplace transform, equal to what? Now, switch your write down. I will do that.
One of this.
suppose this y, the Laplace transform of yt is big values. Now, the second order of yt, it's Laplace transform. How to compute it? We have to compute it.
Double differentiation.
Now we can do this first order vector order t. What? Now by the definition of Laplace transform, what yt and e power minus ft dt. We can move this part to this derivation, and we can get
E inverse ft dt.
and dyt.
Yes.
Now equal to what? Equal to e power t yt and minus yt d. Okay. We can see here if t is empty, tend to empty, and then this part is 0. And t is 0. T0, we can say here is 1, and this part is 0, and minus 0, y0. Only remain minus y0 remain, and we do that continue. Here the derivation of e power minus ft equal to what? It is minus h, and here times minus 1, and this should plus s. You can see here in t and yt e power dt. This part is big fs. So equal to minus y0 plus s big fs. Where this y0 equal to not equal to 0. Y0 is not to equal to 0. And secondly, we can get this the second order derivation of Laplace transform by second order t. Now this part y second order t equal to what? We can see, we can write it. Now simply write it. We can see here it is minus y power first order of yt minus y0 and plus s square and big fs. This is the second order will be it. Then if I have given this result of first order of yt and the second order derivation of yt, then we can do this. We can throw this equation, differential equation. Now for this equation here, I brush it. Okay. Okay. Now, here is the Laplace solution. the Laplace of y 2 order dressing plus yt equal to 0. Equal to 0. And when we get this Laplace transform, second order t and plus yt equal to 0. Equal to 0. Let's see the second order yt. The Laplace transform equal to this part, and the first order. This is this for this. For this. Let's do. Okay. Now we can put this result on this the result of the two results. Substitute this part. This second order derivation of yt, the Laplace transform of it, equal to minus y is 0. Here is minus s and y 0, and also plus s square s and plus here this yt. This is yt. Yt is fs. It's ys. It's ys. We can see here this y0. Y0 is r. Here is r. This is first order of y0 is beta. Now here is minus beta minus s r plus s square, and y is s square plus 1. Here y is equal to 0. So y is equal to minus beta plus sr to s square plus 1. Now how to slow it? That is transform. Now, how to give the result? I remember cosine beta t or sine. What's the result of
cosine?
Cosine beta t, the Laplace transform of cosine beta t what?
Cosine beta t is equal to s by x square plus beta.
Because here, this is beta, but this part is 1.
1.
So,
Beta equal 1.
beta equal to 1? Beta equal to 1? Now, what? Laplace transform equal to 1 by s square plus 1, which is Laplace transform equal to s square plus 1.
Cos beta. S by S cos beta t. Cos t.
Cosine t. And this
Cosine t.
sin t.
No, log t. For sin t is beta is up. This one.
This one?
For sin t is beta is up. This one. Sin beta t equal beta by x square plus beta.
Beta is 1. Beta is 1.
Here beta is 1. But you write here s.
Like this, we can say here. Now, let you see this Laplace transform of cosine t is 1 by s squared plus 1. And this Laplace transform of sin t is equal to s by s squared plus 1. So, we should want to know what's the inverse Laplace transform. Also, we can write Laplace transform, the inverse Laplace transform of 1 by s squared plus 1 equal to what? Equal to cosine t. And the inverse Laplace transform of s by s squared plus 1
Sin t.
equal to sin t. Equal to sin t. So here we want to know the yt. What's the yt? Yt is also the inverse Laplace transform of y big Ys. Big Ys. Big Ys.
So big Y is equal Laplace
So-
transform of Y.
Oh, okay. We should give this inverse Laplace transform of big Ys. Now, the big Ys we can say here divided into two parts. One is equal to beta by s squared plus 1, and the second is s half by s squared plus 1. So, we by this two equation, or we can give the result of it. Would you like to write that on your textbook?
Base.
Would you do it on the blackboard?
What?
No. Okay, never mind.
We have some MATLAB transformation.
What?
MATLAB transformation. Some mathematics.
Oh, but never.
So we here something like this.
This is Laplace is this Laplace transform. Now, let's do it. Equal to what? This is Laplace transform of s squared plus 1 and this big plus this inverse Laplace transform of s r by s squared plus 1. And this is equal to this big, you can move to the front of this inverse. And this alpha also move to this front. Now, this is equal to this base and cosine t and plus r sin t. So this is the solution process of these two examples. You can review it carefully, and if you have any question, please don't hesitate to ask me.
Life is a question mark.
Now she
What?
something. This one. A square or
Oh, no, this is beta. Beta. This is the beta. This beta.
oh,
Beta.
not if
Alpha. It's alpha. This is Laplace transform L. So beta. Have a rest.